Hello, everybody, and welcome to number 17 of the Scaleway Sessions, test-driven live streaming. I am your sometimes and forever host, Dan. I am the head of developer relations here at Scaleway. I am joined, almost as always, by a pair of lovely people. Diego, who is oftentimes behind the scenes, making things happen, doing the typing and the clicking and the sounding and whatnot, joining us today on stream, on camera. So good to see you. Diego, thanks for everything you do behind the scenes. And of course, Eli, who will be doing also some typing and some pointing and clicking and talking on stream with us here today. So full transparency, this is a pre-recorded session. We are not actually doing this live. We generally like to do these sessions live. We stream on Twitch, on YouTube, and we have people come and talk. We have people in the chat. We have people pinging us on the Slacks and whatnot. And we want it to be interactive, and we want it to be fun and get that conversation going. We're not doing that today. The reason we're not doing that today is because today, when you're watching this, assuming you're watching it when we post it, all of us are going to be in Amsterdam for DevOps Days Amsterdam. So it's going to be super, super fun.
Gets me every time, man.
I love that one. I love it every time. So if you are at DevOps Days Amsterdam and you're watching this for some reason, turn this off and come find us, because we really like to talk to you.
You can watch it later.
Yeah, exactly. Why are you watching the record? You can watch it whenever you want. Don't worry about it. Okay, super. So what are we talking about today? I mentioned the name of the title of the session is Test-Driven Live Streaming. Eli, this was your brilliant idea. Walk us through it. What are we talking about today?
I think I came up with this at the end of yesterday on approximately 0 brain cells. So, but we're talking about testing. And obviously test-driven development is a big, it's not just a buzzword, it's a methodology. I've done my fair share of it. I quite like it. I know others have gripes with it, but I was like, well, what are we doing? We're not doing development, we're doing live streaming, and we're talking about tests, so test-driven live streaming.
There you go. Makes sense, right?
Yeah.
So I guess we have a couple little things that we like to do here on Scaleway Sessions. Generally speaking, we have guests come on, we have things we like to plug, things we like to talk about, so on and so forth. And we've been playing around with when exactly to do it. Do we do it in the start? Do we do it in the middle? Do we do it at the end? So I'm just going to say out loud right here, right now, that we've got a ton of stuff coming up that we're doing. At Scaleway, we have our own event series. We're doing meetups. We have the Jam, which is a really cool meetup series that we're doing. We have QB Talks. I don't know how you pronounce it. This is the running gag. How do you pronounce this, right? That we do every month here in Paris. Those are generally francophone, but if you're in Paris, if you speak French, you want to check those out, please do. We'll put some links up. We'll get some stuff a little bit later on. But I just want to get that out of the way just to let you know that if you want to do something live and in person and meet your peers, and you happen to be hanging out in Paris or Lille, come hang out with us. And that's at scaleway.com/en/events. So
the next QB Talks is in 4 days as of airing. It's on the 27th of June this month. So if you're in Paris on the 27th, come hang out. It's a really cool event.
Excellent.
I thought you were going to present the testing thing when you mentioned that, we sometimes do this at the end, at the beginning, the middle.
Oh yeah, no, we're doing some A/B testing here.
I missed the obvious pun. That's it. Stop the recording. We're starting again.
We all got to go home. We're all already home.
Excellent. All right. So let's dive right in on this, and let's talk about testing. Now, we've got a couple different ways that we could approach this, right? We can approach it from a very practical standpoint, like literally what framework should we be using to test a particular language, so on and so forth. And as nerds, and we are all nerds, there's nothing we like better than debating the minutia of a framework, right? Like that is so pure and so good.
Does it do dependency injection in the correct way? Because obviously there's only one correct way.
Exactly.
Right?
There's only the correct way. Exactly. Does it use decorators that I don't hate? Right? Yes. But before we get to all of that, and we are going to get to that, maybe we should just talk a little bit about testing in general. Right?
I have a story here.
Eli, take it away.
I once went to an interview for a job that I thought was software development, software engineer. And it turned out when I walked in the door that it was an interview for test engineer. And so suddenly I had to pivot and be like, why is testing so important? And I got offered the job. So I can clearly talk about testing and it's the currency of trust in your software on the fly. But yeah, I went in and got an offer for a job that was not the job that I thought I was interviewing for.
That's pretty much testing in production right there, isn't it? Right? I mean, but it's your career.
Yeah. So, I didn't actually end up taking
exciting.
that job, but yeah. But yeah, why do software testing? Why not just build something that you know works? If software...
Well, so we're all very good software developers.
Yeah, and I mean, if it takes you twice as long, it takes you as much time to write the test as it does to write the thing. Well, in a given amount of time, you could just build twice as much software, right? I have worked with people
to have any logical flaws whatsoever.
I've worked with people who took that exact ethos and were like, well, in this time we could have shipped a product, or we could have had half a product and half a product's worth of tests. And so we just built the thing without tests. And they're a successful company now, but they still don't have good tests.
Well, but hold on. If they're a successful company, do we need tests?
They have a lot of outages.
You just okay. So they have a lot of outages. So
but they're still successful.
But let's actually talk about that.
They make money. They're not a startup with runway. They are a small business. But
then you need to measure what's your definition of success.
Yeah.
Are your users going to complain if you are down twice a month?
Mm-hmm.
Are they willing to continue to pay for your services or products?
Yeah.
If that's the case, then
is your product good enough to build up enough goodwill that that's an acceptable drawback for your users? Mm-hmm. Yeah.
Then it comes now to... Yeah, then you as a developer, are you happy with the work that you've done?
Well, I wasn't a developer at this company, to be clear. But I did while I was there continually say, hey, maybe we should have more tests. Hey, our users who are developers think we should are beginning to suspect that we don't have tests. Yeah. So for me, I'm a mathematician by training. That's my degree. And if I don't know that something works, if I don't have a reasonable amount of trust in the thing working, either the code has to be so small that I can completely understand it and fit it in my head, which is not the case of most things that you build as a software engineer, or there have to be tests that I trust that are each small enough to fit in my head that I can delegate that trust to, right? Does that make sense? That's why I would put tests in my software, even if I'm just building it for myself. Because you want to break down the failures into things that are small enough you can reason about them.
Okay, so yes, I agree with that, but I feel like we haven't actually yet addressed the first part of this, which is there was a company and the company is successful and it makes money and they don't write tests. So while it's all nice and true and good to go, oh, we need to do test-driven development, and oh, we need to do complete end-to-end, and this, that, the other thing, we got to have staging environments. Like, this is lovely, but if we already start with the premise that you can run a successful company built on top of software that doesn't have tests, do we need tests? I'm still unconvinced by this argument.
I think that, so in this particular scenario, the bulk of the software was understood by the two people who wrote it. Onboarding a new engineer into that, in order to work on it without breaking things, they have to then absorb all of that understanding. I'm not sure if that's even possible for somebody who didn't grow it in their head, And I never saw it done. I never saw them onboard an engineer into the real inner workings of a lot of that platform. And I think tests are a way of describing the behavior of your system in a way that makes it clear, like, this is how this should work. They're almost like tests as documentation, almost. They describe the behavior that you need out of your system. And if that behavior just lives in somebody's head, it's a lot harder to transfer. I mean, it doesn't scale, right? So I think that you need them if you're going to Like if you're going to describe the desired behavior of your system anyway, in order to transmit it from one person's head to another when you onboard new people, why not just write that as tests? And then you get all the good CI/CD goodness of, I broke the build for free almost. That you have to do this work anyway. So why not do it as tests? That's not a position I had considered before, but I've just talked myself into it.
Yeah, I've never thought about tests as documentation, actually.
It's kind of what test-driven development, or at least behavior-driven development, I think, is about. It's you describe what you want, and then you write the thing that satisfies those tests, even if it's ugly, even if it's not what you think it should be. If it does what it's meant to do, then you've built the right thing. Mm-hmm. That's the ethos of like test-driven development, is you describe up front your success criteria and your spec. You turn your spec from I want a thing that does this into code, and that's tests. And then you write a thing that makes those tests pass. And I think you need that description of what your system does as a business asset. So it might as well be a code asset.
Business asset, a description of what the thing does as a business asset. Walk me through
I guess
that.
Not necessarily business asset, but for onboarding new engineers, for describing, well, you can't make this change to the code because it breaks this test. But what that test is actually saying is it needs to fulfill this. It needs to do this thing. Our software needs to behave in this particular way for a business reason at the end of the day. And if you break a test, you're saying that you have failed to fulfill that business condition, right? Mm-hmm. I warned Diego and Dan before we started that like a lot of the questions that I put in our little planning doc were like high level philosophical ones because I love talking about this stuff. But I mean, given that it is possible to write software that just works and not have tests, like let's say you build a piece of software and you use tests in development of it. If you got rid of those tests from the code base, software will still work. You don't need to be using CPU cycles and running them all the time. If you're not going to make changes to your software, why still have them? And I think the answer is more subtle than just because it lets you know when your code is broken.
Right. So, okay, I think I'm coming around here. This is interesting. Now, it's true that, and again, full transparency, because why not, right? A lot of times, all three of us are broadly in alignment on our topics. When we start talking about a thing, we're like, oh yeah, we all kind of more or less agree on DevOps, or oh, we all kind of more or less agree on Kubernetes, right? But when it comes to the subject of testing, I'm not philosophically against testing, but I'm not going to sit here and pretend like I write a lot of tests for my code, or even have historically done so, because I have not, right? But this idea that testing isn't just about whether your code does what you think it's supposed to do, or having some sort of, mathematical proof because everybody loves math,
yeah, you can't actually have a mathematically, like proving mathematically that code works the way you think it does only works for tiny pieces of code. You can't do that on a code base.
All of a sudden, all the Haskell programmers up in our DMs now. But
yeah. No, I mean, please come on stream. Come and argue with us, please.
Yeah, come on stream.
And when we do Haskell for our like hacking on stream, we'll
oh my god.
Yeah.
Yeah. When our roulette finally lands on Haskell, right? Exactly. But this idea that tests are maybe not just about the code, but actually about business continuity, right?
Yeah.
That the tests themselves are part of your business's capacity to prove that it can run.
Yeah.
Right. That's very interesting.
I reference this talk by my friend constantly, a guy called David Whitney, and the talk is called, I think, Intentional Design in Code, something like that. And he has this phrase, which is software as literature constrained. I think I mentioned this in the talk we had with Kerem, actually. Software is literature that we are writing to communicate with each other, but it's constrained by being something that computers can also interpret as instructions. We're describing business problems to each other in a way that lets a computer do work on them. And tests are a part of that communication. So that, I mean, It's also, you said what we think about how our code is supposed to run. Tests are also a way to interrogate that and interrogate those assumptions about, well, I think my code needs to do this, but actually does it? Could it be done a different way? Am I just thinking about this because it's how it's been done before in my career or in the industry? You don't go that deep every single time. A lot of tests are just, did I accidentally break something with a typo? But they are a tool that you can use to do that.
Yes. So it's funny because I'm pausing here because I'm really actually trying to digest everything you're saying. This is.
Oh, I've got a whole conference talk in here apparently.
Apparently you do. I'm feeling the energy here.
Yeah,
I like testing. Yeah, this is really super interesting. So, okay, so sort of that first question that we posed, which was, why don't we just write software that we know that it works? Right? So right there, we start with that premise. How do we know that it works?
And how do you communicate that knowledge?
And how do you communicate that? Right? How do you demonstrate
first question
that?
I think those are two different questions. So
yeah, no, that absolutely
are different questions. Yes.
Yeah. So the first one is, how do you know it works? You know what you want to do, right? You have a set of designs and expectations of the feature that you want to code.
Yeah, you have like success criteria.
What you want to do, and you know what's the result, because you need to know that beforehand in order to code it, right? So you as a programmer yourself, only one person knows what your goal is. That's good. You're one person. Then you have a team.
2 people who are drift compatible in my experience, but yes.
But then you have a distributed team or some other people that may be joining your team in the future. That's when
that knowledge needs to be in everybody's head, or that knowledge needs to be available to everyone, whether or not it's contained within everybody's head and it's the same, and nobody has any different interpretations of it, or some other mechanism for transferring that it works.
Right. But then the part when you say that tests are a sort of documentation for your project is the part that kind of makes sense to me, but kind of doesn't, because you still have your success criteria and your tickets and your Confluence pages describing
how your
app's supposed to work, and they do it in detail with actual human readable text and diagrams and pictures and all that.
Yeah. When I say documentation, I mean, like, it depends on the tests that you're talking about. Obviously, like, unit tests at a very low level are very much like, this is what this function does. This is how this function behaves with these inputs and what outputs it's supposed to give. But when you get to sort of end-to-end testing or integration tests, it does actually kind of become more comparable to the kind of documentation you're talking about. You're saying, okay, if I send this kind of message into my routing component, this is what I expect it to do as a result with these in this context. And then you can see how it relates to like the overall function of your piece of software. Like if I do this to it, this is what happens on a high, like at a broader scale than just like individual unit tests.
Right.
So unit tests are useful for, I made a typo, I mucked up the signature of this function and now nothing works, or, and also as part of that continuity of going, okay, I'm looking at this one line of code and now I can see how it fits into the picture of what this software does. They're not documentation in the same way that they're not user documentation. They're developer documentation. Totally. Yeah.
I think I get your point, but now would it make more sense for this developer to actually just read the code of that part of the system? Because the code is actually describing what it's doing.
It is describing what it's doing.
And so maybe comment it.
Yeah. You don't necessarily know, reading that code, which behaviors are important or not. So it may be that there's a certain code path that's never meant to be traveled down. And that's not, it should be commented, right? Or like, I don't know, by this point, if you've got to here, the input from this will never be 0 or something. And maybe that's not important. Maybe if it ever is, that won't throw an error. But if it is, if there are behaviors that you really want to preserve about your system, that's what tests are for, right? Because if you change that, they should break and go, this is wrong. And tests tell you that. Tests tell you this behavior is important to the functioning of the system. But you wouldn't test things that aren't success criteria. You don't test, you do this. Again, this is kind of the test-driven development thing, where your tests describe the desired behavior of your system, not the actual behavior of your system. Because otherwise, every single time you made a code change, the test will break. You're not describing what is, you're describing what should be. And hopefully your code fulfills that. But there are degrees of freedom outside of that you might not care about. And that knowledge is not encoded in the code. That if I just read a function, I don't know whether or not a certain behavior that it has is important or not to its business function.
So that actually
I said a lot of words there. I don't know if they made sense.
No, it makes sense, and I think if I'm following this, let's work through a practical example. Say you've got a, pick your programming language, but some sort of a switch function, right? Case switch, whatever it is in your language, right? And you've got some possibilities there. So you've enumerated some possibilities. Okay, if it's true or if it's false, those are possibilities, right? But what if your language has other states other than true and false? It could be null, it could be like so on and so forth, right? And so it starts to get a little thornier there. And if you're doing a switch on some sort of arbitrary value, like a string, right? Or a specific set of integers, if you're, reading, I don't know, database IDs or something, right? There, the code is saying, here are 15 possibilities, right? And any of those possibilities is going to send you down some sort of code path towards some sort of direction. They'll all be successes. That doesn't necessarily mean the business logic is good and successful, but those will all trigger successes, right? That's what the code says. So if I'm just looking at the code, I'm going, oh, we're interested in 15 options. Let us learn about 15 options. But what is going unsaid there without the test, and which requires higher order analysis, again without the test, is we're expecting a value and that we have values, but other values could come. Right? We don't need unit tests for every one of those values. That doesn't make sense necessarily, right? Because that's not actually what we're testing. We're testing whether the switch case is capable of handling what gets thrown at it, not what actually is the result of what gets thrown at it. And the test describes that very succinctly, right? I just needed a whole bunch of words to express that idea, or literally this much test. It would say exactly the same thing.
And in a language that your programmer already understands. That, like, you can read that code and go, I know what this is telling me. This is comprehensible as like, this is describing the behavior of this function in a way that exactly the same amount of English prose is harder to digest and less precise.
That is really interesting. And I have to be honest with you, it is not an aspect or not a way of thinking about tests that I've ever thought about right prior to right now.
Maybe I've got to write that conference talk. And a big hat tip to my friend David.
I want to attend that conference. I want to attend that conference.
Add it to the list. So. I was talking with Diego earlier about all the conference talks I'm going to write.
Geez, that sounds okay. So
and I think
I'm sitting here having like kind of a come to religion moment here with tests.
I mean, it's always going to be context specific, because if it's communication, and the thing about that also is that as a single developer working on a project, sometimes the person you're communicating with is your future self. When all of my all of my current context has fallen out of my brain, like my brain is a sieve, and in the future I go back and I read my tests and go, that's what I wanted to happen here. Now, and if I've commented it, now I understand why. And it's again, like, communication doesn't stop being important just because you're the only person involved.
Right.
Yeah. I had a job three jobs ago. Yeah. Where one of my two managers was like really had all of this philosophical like grounding in testing. And so I absorbed some of that. And I think that's why like tests as communication and as context and as sort of description of behavior is why test-driven behavior and behavior-driven development, test-driven development, behavior-driven development, they have caught on in that sense, is because they are bringing that, they're making that explicit, that that's what they are, is that they're a description of your code-to-side behavior, and that in and of itself is valuable. And we can write it in a way that computers can do work on and get mechanical benefits as well, like testing pipelines.
So let's dive into that. I've read about test-driven development, and we can talk about that. But behavior-driven development, I've seen the phrase, but I don't know what that is.
I'm just going to go and Google it to make sure that I think that it is what I think it is. Because what is it? Agile software development process encourages collaboration among developers. It emerged from test-driven development. Okay, so it's essentially like that, but on a higher level of like, okay, how are our customers going to use this? And what's the domain we're trying to serve? And can we encode those ideas also into something we can get a computer to do work on? My experience with this has been with the Gherkin language for developing, for describing. Gherkin is really, really funny. It's like this language where you write what looks like English, and then it can be parsed and broken down by various engines and what's the word I'm looking for? Runtimes, interpreters, and turned into like, it's sort of like the must should type thing of the IETF guidelines of like, this behavior does this when this is this. And it's sort of this thing that's been, the idea is that you can take that to shareholders or stakeholders and go, this is what our system will do. But it's language that's constrained in a way that you can put it in a computer, and they describe tests. So like when I like for each variable in this file that I've got, the behavior will match this other, like you can give it a matrix of inputs and outputs. And it's a way for describing tests at a higher level of like human comprehensibility than the lower level of code. Diego's put something up on screen. Yeah, the two concepts to me seem to be very closely linked.
Oh, we are just
I unfortunately cannot see. I can't see the live screen for some reason. It's just a spinny thing for me. So I appreciate that you let me. Yeah. I don't know what's going on right now, which is a lot of fun. But you mentioned the IETF paper there. For those of you who are not familiar, IETF RFC 2119, right, which is one of the great RFCs in the pantheon of RFCs in the hallowed halls. That's going to go to town. There's going to be these pyramids, and 2,000 years from now, space archaeologists are going to come down to Earth, and they're going to unearth the pyramids, and they're going to dig down inside, and they go, what important thing did these people worship? What was so sacred that they needed to house them in these magnificent archaeologies? And they're going to unearth a scroll, and it's going to say the keywords must not, required, shall, and shall not in this document are to be interpreted as described in RFC 2119.
My favorite joke about that is you should write your wedding vows using that.
Yeah.
But yeah, so that kind of idea of formalizing language to have meanings that are concrete and sort of parsable by computers. I mean, that's what coding is, right? That's what software development is. And Gherkin as a BDD tool is a language that is widely used to do that and be comprehensible at a high enough level that people who are not developers can get meaning out of it, and maybe even write their own guidelines. Like you go to your stakeholders and say, okay, here's how you write these things. Here's how you encode what you want into this slightly more constrained English. And then we can take that and go do work on it. And it has the great benefit that if you build something and your stakeholders go, that's not what I wanted, you can go, yes, it is. You wrote this.
Well, it's not. It is not necessary. Maybe it's not what they wanted, right?
And the people part of it will never go away. Like, getting people to actually accurately, precisely describe what they want is why ChatGPT is not going to take any of our jobs anytime soon, because people can't do that.
Strong words.
People can't. It's a hard problem.
It is a hard problem.
And you need years and years of doing it to be any good at it, I think.
Speaking of these kind of new tools that are out there, what about letting them write the tests for you? Unit tests in this case, just scope it down to that.
I mean, going back to the whole tests as describing the desired behavior of your system, the tool needs to understand what that is in order to write the tests that you actually need.
So in this case, we're talking about unit tests, right? So
yeah, but I mean, you don't just want to test every possible property of your system, because some of those aren't important and can be allowed to change. If you write unit tests that just fossilize your function in place, all that means is that you just have to regenerate unit tests every time you change anything.
Right.
Your tests should only test the things that are important. Otherwise, you're just creating busy work for yourself. And oh, I changed this function. Oh, of course the unit tests broke because I changed something. Let me just regenerate them real quick. And then suddenly they're not valuable because you don't know if you broke something that meant something.
Yeah, but then how are you going to get the 100% test coverage badge in your README on GitHub if you do it that way?
There's a repository I know that has 100% test coverage, and it's Kelsey Hightower's no-code repository.
I think we're obligated every single Scaleway
I will
Sessions
keep bringing it up because it's one of my favorite jokes on the internet.
to evoke Kelsey Hightower, no code. Yes. It does have 100% test coverage. One might say it has infinite test coverage.
0 over 0 is undefined.
Exactly. So. It has NaN test coverage.
Yeah, I mean, test coverage is is a hot. It's debated as to what it signifies. It's always going to be context dependent. You know, if you want to test every single code branch, which ideally you should, if they are important code branches, if that knowledge is important, and if they're not, why are you writing the code? Yeah, but is it the most important metric? I don't know. If we think about tests as not necessarily purely mechanical, but also for the purpose of communication, then suddenly they're serving a different purpose than just by rote covering your entire code base.
I'm reminded of a debate that we had at Mozilla years ago when it was decided, I don't know if it was a person that decided it or one of these sort of organism making a decision through consensus, something Mozilla, that we needed to test stuff. Great. And so there was this huge push internally on a particular fairly significant Python application that had been written to write tests for everything. And the goal was 100% test coverage, because why wouldn't you want 100% test coverage? And the amount of engineering hours that went into trying to achieve that goal over months and months and months was staggering. Now, I'm not going to say it was wasted effort, because it wasn't. In fact, tests were written and flaws were found.
Yeah,
because that's what happens when you start testing your code. You go, whoops, like this is actually a really bad bug, and now we have to put that on the next sprint and blah blah blah.
Gosh, I can't believe this hasn't wrecked us yet. You know.
Yeah. Exactly. Yeah. Right. However, it also meant that it had the side effect of exactly what you described, which was every time something changed somewhere, the test broke. And then there was this sort of vicious cycle of people almost not wanting to change anything, because then they'd have to like run the test suite, and the test suite takes an hour to like find the one thing that broke. You know what I mean?
This is one of the things I really like about a lot of the testing frameworks I've used, is that you can have that level of granularity of, I just want the tests that are associated with this one specific thing. And obviously that means you have to have a sensible hierarchy and organization of your test code. But when you do, it can really reduce that friction. But yeah, the signal to noise ratio of like test breakages, that's something to optimize. But obviously that's very difficult to actually describe to something like ChatGPT.
Well, there you go. And then the other thing that happened is that there would be tests that would break. And the developer would be like, actually, don't worry about that. The test is faulty.
Intermittent breaking tests are one of the worst things that I've experienced in my software development life.
Yeah.
Right? because then, and this is going to sound like I'm making it up, but this is an absolutely true story. This is where I want to go with it. Was someone went, oh, I guess we should test the tests, right? Because here's a test that sometimes doesn't break and sometimes does break, and it's code, and we test code. So should we test the tests? And then there was a whole rigmarole around that, and yeah, exactly. And then it's like, who watches the watchers, and like, how deep does this rabbit hole go? And suffice it to say that that was a significant mess for a while, until everybody decided, you know what, maybe we don't need to test everything all the time. And then that just sort of stopped being a thing.
So
and again, I'm not saying that was a good outcome. I'm saying that's what happened.
There is a tool that I think might have, I mean, depending on the frameworks and depending on all the sort of low-level specifics, there's a thing called property-based testing, which I was fortunate enough, let me go and find another talk on YouTube, fortunate enough to see a really great talk by somebody called Lucy Mayer, also at NDC London this year. Property-based testing is essentially, you have a framework where you describe the properties of your test, and then the framework will generate loads and loads of inputs and make sure that the quality you have described holds true for all of those cases. And I'm not going to do as good a job as Lucy did in their talk, but something like that, you could say, here is a test, and here is what I want to see out of it. And then you could inspect the breakages and look for patterns in the inputs. And that's a sort of quick way to do the tests of your test. Obviously, this is designed for functions, like here I've got a function, but if you have a test, again, it's code, you can do that to it. And with intermittently breaking tests, that might be a good way to narrow down all of the sort of millions of possibilities that could be causing it.
So it's sort of, I mean, it's very meta, isn't it? Right? Like, it's, instead of saying what I'm particularly interested in is this piece of code's capacity to deal with this input and produce this output, right? Like that's the test, quote unquote, for example, that's a test, right? But then what you're saying is, there's like, let's rub this other sort of layer on it, on the test, not the actual piece of code, where you're saying, I want the test to be able to deal with the concepts, right? Like you're removing yourself from what is literally the input and the output. And is it even about primitives at that point, right?
Well,
like,
tests are just, in my experience, they're just functions, right? They're functions that you run. And you can vary the conditions of those functions. I mean, you shouldn't be. That's why you have like setup and teardown functions, right? For your tests.
Right.
You ideally are running them in the same conditions every time. But if you've got an intermittently failing test, that's clearly not true. And that's the case when it would make sense to do this kind of testing.
Right.
Is if you suspect that an assumption about your test conditions is false. The assumption being that the inputs and outputs are the same every time.
What if they aren't?
Yeah, what if they aren't, without you having changed the code, the code, which is the input, as it were. If you haven't changed that input and your test is sometimes failing, sometimes passing, something else must be changing.
Right. With the test harness is haunted, for example.
Yeah. Cock's gun, test harness is haunted.
Yeah, exactly. Yeah. Test harness is haunted. What?
It's haunted. Yeah.
It's haunted.
Just every time something really weird goes wrong with computers, I'm reminded of the story about the Super Mario speedrunner who got a world record because we think a tachyon hit, or a neutrino hit a bit of hardware as he was running and flipped a bit. And that's why the world, I don't know if it's still the world record, but I'm going to go and Google this now because I can't remember if it's like apocryphal.
That's incredible. I love it. I want that to be true so badly.
I mean, what changed?
Let me go and have a look. Cosmic Ray bit flips assists Mario
Eli's
64.
Looking for that. Well, Eli's looking for that. There's
I found it.
Donkey Kong, right? And Donkey Kong, for those of you who are not as old as me, was an arcade game which you played on a machine with a television in it with buttons and a controller.
I've been to a museum that has that in.
Yeah,
As the Sheffield Video Game Museum.
To be fair, I was also very young when Donkey Kong came out. I'm not that old, but nonetheless, right? And the thing was, is these were not computers with software as we understand it today. These were electronics, right? And hand soldered with wiring and resistors, and the boards inside them were put together by real human beings. They didn't come off of a factory line, and so they had weird idiosyncrasies depending on who was doing the connectors, and different types of cabling and different types of distances, and all this sort of really low-level electrical stuff, which meant that every single cabinet behaved a little differently. It was the same game, but the patterns inside of the game, the response time, subtle little things were never the same cabinet to cabinet, which meant that when you had people doing championships to see, how far could you go without getting hit by the barrel or whatever in the game, and people would play for long periods of time, and the game would get progressively harder and harder and harder and harder until it was unplayable, depended entirely on which cabinet you were playing on.
Mm-hmm.
Some cabinets were easier than others, and so you could have a easier time getting a world record, right? Which was super interesting. Yeah.
Yeah, there are loads of rules these days in speedrunning, and before this becomes like a speedrunning live stream about speedrunning, but yeah, about like how much are you allowed to influence the hardware that you can afford today to how much are you allowed to let that influence your times? Like, if you can up the clock speed on your PC, will that let some game run faster in a way that allows you to get a better time? And if so, are we not restricting speedrunning to people who can afford to shell out for really high-end hardware? I think it's, depending on the speedrunning community, it's an ongoing debate. But yeah, that's super cool. I found the article about the bit flip in the Super Mario speedrunning contest. And the thing that always astonishes me about that story is the depth of knowledge, and it's sort of how intimate you have to be with the game, how completely you have to know it in order to recognize that that's even happened. But yeah, super cool. So, anyway, whenever we have a weird computer fault, I always think of that. Maybe it was a cosmic ray. Maybe that's why my test is intermittently failing. I'd like to see the test harness that can find that.
That happens. It's not like it happens all the time, every day to everybody, but it is a real, actual thing that happens. And I'm once again reminded of another tale from my days as a system administrator, where we had a series of identical load balancers, literally identical. Like, they were hardware load balancers. They were sequential serial numbers. They were configured. The firmware was identical. They're configured from exactly the same source file. And out of the blue, one of them one day just started routing things incorrectly by like 1 octet.
Yeah.
Just 1 octet of difference, and it was sending things to the wrong destination in one specific. Nothing changed. There was no updates. There was no power fluctuations.
Cosmic
Nobody
ray
touched these machines. Just cosmic ray, flipped a bit, rebooted it. It was fine.
Amazing.
Like,
yeah, I mean, one of the things I've done, so I have this talk that I've given once, and I'm about to give it again a few times, about learning about the history of hardware storage, hardware data storage, like how do we physically turn ideas into physical objects, and the fact that like flash memory leaks over time, and most hard drives have a flash memory controller. So that's also true of, like, if the flash memory in your external hard drive rather goes, if it's encrypted at all, you just won't be able to get the data out of that hard drive back again. And this is fine because you rarely write to that flash memory, so it's actually fairly stable. But just, how much can we trust our assumptions about even the very physical objects that we run our code on? And then as you go up higher levels of abstraction, and as all of those abstractions leak, how much can you trust all of those? Until suddenly you have intermittent tests, and you've got to do property-based testing to figure out where in that entire massive layer of things has something gone wrong.
So this is coming back down to, or we've looped away, and we're coming back down to these like wild philosophical
philosophy hour with Eli. Yes.
Right. Exactly. Which I'm here for it. That's 100%. But let's see if we can smush our two topics here together. So we've got speed running and we've got tests.
Mhm.
And so I mean, spoiler alert, I like a good speed run. And there's, assisted speed runs and unassisted speed runs, right? And then there's, speed runs where you're allowed to exploit the mechanics of the game in ways that were unintended, and there are speed runs where you're supposed to just do it pure, et cetera, right? So there's
And
all
what
these different
counts
ways of
as
thinking about
a glitch
what
or not.
counts as
Or...
exactly, is it a glitch? What if we jump backwards and we jump backwards slightly differently than if we jump forward, et cetera, right? And that's fine. But like all of these things are testable, right?
Right.
These are all things that we could be writing tests for as software. What's a video game software, right? So we're software developers, we're writing our video game. We could be writing tests for this stuff.
But
I concede that testing, whether if you turn your character backwards and then jump in that direction and you happen to be holding stick of +9 alacrity, and there's monster number 92 on the left side of the screen at exactly that moment,
and there's a buffer overflow, and suddenly you have infinite money and infinite speed.
Right, these like incredibly complicated, like emergent properties of systems.
The Fallout 3 speedrun is like that, and it's so good.
Oh my god, yeah. Morrowind speedrunner, you ever seen that? Right? Oh my god. Goes from like getting off the boat to killing Vivek in like 3 seconds. What just happened?
Yeah, and it's like I've got to jump backwards and I've got to be injured about this amount, and then if I do that, the game won't register that I've stopped falling and will keep my falling speed, and now I have that as running speed, and yeah.
It's wild, right?
I think a lot of the testing for that kind of thing in video game development is you hire speedrunners and you get them to try the things that they know have broken with the same engine before, because like Fallout is based on the same engine as well.
But there's still probably some tests.
Oh yeah,
right?
But
yeah,
the stuff you don't even know to test.
Everything. You can't test every single scenario with so many different variables that happen at runtime.
And there may be loads and loads of things that a tool-assisted speedrun could do. Like technically, if you get it frame perfect in a 60 FPS game, you could break it. But that a human would never realistically be able to do. And that's why you want, because the success criteria of your game should be the human experience. So that's why you get the humans to test it, because that's actually describing the desired behavior of your system, is that humans should not be able to break it. But, yeah.
Right. There should be guardrails to prevent that from occurring, at least, right?
Mm-hmm.
But now, if we come back to our first argument about does it make sense to invest a lot in testing if it's actually a successful game and people are so happy to play it that are running speed runs? We're still selling the game. It has some bugs here and there, but people are happy to play it. What's the success criteria? Why should we invest more?
That depends on all your business constraints, doesn't it?
Right.
Yeah. So as someone who spent more years than I would like to admit in the video game industry, this is one of those things where there's a ton of things in a video game that don't have to work for the user. The user will just ignore it. Honestly, if other things do work, like there's a value proposition there. There's a bunch of different ways of thinking about it. There's pyramids, there's matrices, there's a lot of different ideas around literally what it is, right? But it all comes down to this sort of basic idea, which is if you get a certain set of things right, everything else can be wrong, right? And this also speaks to what you were mentioning, Eli, about, well, what do you test? You test the things that matter, right? So we test the things that matter. We make sure those are correct, and the rest, whatever, we'll just patch it. We'll sell somebody a thing for 20 euros later. It's fine, right?
DLC.
We'll call it DLC.
Yeah.
Yeah, sure, right? And so, but those things change from game to game, right? So what has to work, for example, in Fallout 4 or Skyrim, right? What has to work there is different in some ways than what has to work in Call of Duty. Even though they're both first-person games, even though they both have character progression, in fact, and then is itself different from what has to work in like some puzzle-driven game, Candy Crush, right? was then again, and so on and so forth.
Exactly.
A lot of other things can break, and no one cares.
And then you get into like,
One,
so go on.
I was about to say, but if there's like one thing where that one thing has to be just right, and not just not broken, but perfect. Because anything less than perfection will feel broken.
Yeah. And I think often with games, that's the things that I'm thinking of in games that I've loved. It's like the difficulty progression has to be right. How do you test that other than manual testing, humans? How do you
Obsessively
encode
playing
that?
it over and over again.
Yeah.
Yeah.
It's one of the reasons why video game development is really hard, because it's something where the user experience really is central, which is interesting to us as developer advocates, I guess.
Right. So okay, let's move on with the continue with the game topic. So two examples come to mind right now. The latest, The Legend of Zelda, where you were able to craft some weird stuff that you were not supposed to do, but
It was
people
Extremely long bridges.
civil engineering atrocities. Yeah.
But people were happy to play it and experiment with this unintentional feature, right? So that was good. Now, remember Cyberpunk?
I never played. I haven't played the new Zelda, and I never played Cyberpunk. But I'm immersed in the
Right.
gaming news world. Yeah.
Exactly. So Cyberpunk was
It was a disaster
fun.
on launch.
Yeah.
It's super playable now. It's actually a lot of fun.
But during launch and probably how many months, people were really unhappy. I
No
got
Man's
it.
Sky
I
had
got
the
it.
same. Yeah.
I bought a Stadia, the Google gaming product. That
Have they
is
killed
no
that yet?
longer.
Is that dead yet?
Yeah, it's dead.
Yeah.
I have a controller, and that's it. So I requested a refund actually because it was not playable,
Yeah.
and that was the case with so many people.
I'm
then.
somebody who doesn't get games until way after the fact. Like I'll watch live streamers play them, especially on launch because it's fun. But like I got into Stardew Valley way late. I get the Pokemon games way after. Especially the new ones, because it's like, oh, they very much the DLC, it works now. Or like, the day 2 patch where it's like, oh, we've made it actually workable. That's so much of a thing these days. I remember when I was a kid and you could just go and buy a cartridge and it just worked. But, yeah, I think with especially like AAA games like that, the complexity there is so enormous. Like this kind of surface of what you have to test. Like you've got things like the difficulty progression and like the overarching game design stuff, and then you have all of the mechanical stuff, and then you have the look and feel of the game, and all of these are really, really important. And yeah, how do you test those? How much of that can be automated?
A good way to test things, and and this perhaps wraps it all back together, is a good way to test things is to put it in front of people, right? And this is why things like beta or alpha or in progress type games. To be clear, I do not play these games. I'm actually uninterested in being part of an unfinished game. I don't have the time. I just don't. But I understand the value there, and you have these sort of communities of people that will purchase the game at a fraction of whatever the final price is going to be, and iterate through and comment on it. And a lot of times these comment boards are super toxic, and you're getting a bunch of feedback you don't want. But inside of that feedback, you're going to get really good stuff, right? And I'm reminded of a video game called Terraria. It came out quite a long time ago. It's not a new game. I'm trying to think of when it came out now. It was like, it's got to be over 10 years now.
Yeah.
It's a little 2D side-scroller sandbox thing.
People compare it to Minecraft and Stardew Valley.
2D
both.
Minecraft, sort of. Sure, like little 2D Minecraft. Let's call it that. And it was super fun. It is today one of the best-selling video games of all time, because it continues to sell even 10 or more years later. So over time, one of the best-selling video games of all time. When it came out, like a lot of video games, it was riddled with bugs, right? Because it's a video game. But people were playing it and doing this thing that will do in Bethesda titles, or in the Zelda title that we just evoked earlier, which is while you're intellectually aware that this is probably a bug,
You're
like,
enjoying it anyway.
you're going, actually, here are some weird and fun ways I can exploit this,
Yeah.
and let's see what we can do in the game as a result of that. And then that feedback coming back to the developers and them going, actually, that's really cool. Now it's a feature.
Yeah, I mean, another tech talk I have is about running public betas as a software developer or as a developer advocate, and like gathering that kind of thing. And one of the things I stress is people are going to be using the thing in ways you had not intended.
Yep.
That you cannot predict how people will pick up the thing that you thought was a hammer and use it as a wrench. You know,
Well, people will pick up the thing they thought was a hammer and use it as a duck.
Yeah,
I
yeah.
mean,
And they'll use the duck as the hammer. And
Yes.
you know, it's up to you as the person who continues to evolve that thing,
Yep.
whether or not you want to incorporate it or whether or not you want to fix it and risk annoying the people who have now got that XKCD comic about you changed it and now I can't use my space bar to heat up my
to
computer.
heat up my
and,
CPU, yeah,
and
just give
yeah,
me that
exactly.
option again, exactly. Yeah.
And you know, you have to balance where you want to go with your product versus the people who versus the value it's already providing to people.
Yeah.
Whether it's solving a business problem for them or they're having fun building weird atrocities out of barrels and whatever in Zelda.
Well, both of those things can be true.
Mhm.
By the way, absolutely. I mean, we could find derived business value from building atrocities out of barrels in a video game.
I mean, we're talking about it
exclusive.
on stream right now as part of our day jobs. That's
Precisely.
business value.
So there you go. All right. Speaking of day jobs, I did mention this at the very start because we are coming up. By the way, we're coming up to an hour. I know the time goes super fast where we're here together, we're chatting, but we want to be respectful of everybody's time. And I mentioned this at the start. We do events, and we like to have people come out. We like to have discussions. We like to have conversations. Doing stuff online and virtual on Twitch, pre-recorded, whatever, it's fine and it's great. And thank you so much for being a part of this experience with us, even after the fact. But we also like to see people in person, and at Scaleway, we do have some events. And so if you go check out https:// scaleway.com/en/events, you can see that we've got a couple of really good events coming up in the very near future as of the airing of this. Two in particular coming up both on the 27th of June. We have in the city of Paris, The Jam, which is an event that I MC. So if you like my style and you'd like to come see me in person, I will be there. We have a really, really cool event coming up on the 27th. Excuse me. Where we've actually got Adam Surak, who's the head of platform at Be Real social media platform. They don't speak publicly. It's the first time they've ever done a talk in public. So that's really cool. And he's going to be talking about this idea that basically every day is a Black Friday, multiple times per day at Be Real, because that is their usage pattern.
Right.
And how do you build infrastructure to deal with that? Which is going to be a really, really interesting talk.
Yeah.
And we're also going to have Dustin Coates, who is the principal product manager at Algolia. Algolia is a search as a service provider. And he's going to be talking about basically, prompt engineering and the rise of AI and how that's changing certainly how we think about search, but also how we think about software development. So those will be super interesting talks. Those are both in English. Don't need to be a French speaker. So if you have to be in Paris on the 27th, please come through and check that out. In Lille on the same day, which is a city in northern France, which is not so far as the flow cries from Amsterdam. Crow flies.
No, I think you're good. Keep it.
I got it right. There we go. Exactly. That's going to be Cube Talks. And there we're going to have, and again, this will be in French, Stéphane Descens, the CTO of Le Fourgon, who is going to be talking about basically how they did a whole symphony stack, cron jobs, security, CI/CD integration, so on and so forth, on top of a capsule. So that's our Kubernetes product. It'll be super cool. And then we also have Bruno Flamand, who's a DevSecOps engineer focusing on Kubernetes at We Speak, who's going to be talking about how you do tracing of services inside of a Kubernetes environment.
Ooh.
So yeah, so definitely come check that out.
That's in French.
And those will be in French. They'll be in Lille.
I have to learn French to listen to that second talk.
There you go. But come to the Jam. It's going to be super, super good. And that's it for the event plugs. We are at an hour. So thank you so
Yeah.
much, Diego. Thank you so much, Eli, for the really cool suggestion on the topic today. And as always, thank you to you, the audience, for sending us your suggestions. A lot of the things we choose to talk about, a lot of the guests that we have on the show actually come from suggestions and referrals and introductions that you're making. So please continue to send those. Please continue to interact with us during our live sessions. We really, really like that.
And please leave comments below on YouTube. I don't think you
Yes,
can do that on Twitch. It'll just be a vlog,
smash
but
the like and subscribe button.
hit the bell.
Right?
But yeah,
Yeah.
leave us comments if you have anything to say, if you have fun speedrunning stories to share or anything like that. We love to
For
read
sure.
them. So.
For
Or
sure.
you can email Dan.
Or you just
Yes.
just hit me up directly. It's all good. If you've been a fan of Scaleway Sessions since the start, you know my email address, so don't worry about it.
Sign them up for the mailing list that you can think of.
Exactly. Anyways, that's it for us. Thank you as always, and as always, stay safe, everybody. Bye-bye.
Bye.